Okay, example 11, this is actually 11b. We're looking at calculate what fraction of sample will remain after 1,000 years. So after 1,000 years have passed, how much sample will remain? So now we're going to look at something called percent remains. This piece right here in red, I would jot down somewhere that you can find it very quickly, because this will be something you will do quite frequently in your calculations. Often you're going to ask how much is left over, how much remains. Percent remains can be found by taking the final concentration over the initial concentration, or we can say the later concentration over the beginning concentration. You will divide those two values. So this is very important that you have the A and the A naught in the proper position. Okay, so this is asking us to figure out what that fraction is. So what this relationship is. We're going to go then for the natural log, because we know it's first order of initial concentration over final concentration equals K times T. And then we're going to know that we have a amount of K. This is our K, pardon me. This is not the amount, this is K. And our K is consistent throughout a problem. And then it says 1,000 years, so I want to know how much sample remains, the fraction of sample that remains after 1,000 years. So when I do this math, I get this value. We're going to E both sides. When I E both sides, I get a numeric on the number side. And when I E an ln, right? And this should be really ln here. Let me try figuring. Okay, that looks a little bit better. When I E an ln, remember what that does? It's like I delete these two, and this part just falls down. So it's like you're erasing those or deleting those, and this falls down. I E this number, and I put this E to the X in my calculator. Remember, that's the second function of your ln button, and I get these values. And then I'm going to figure out what fraction remains. So what's important here is the word remains. So I know I have to get it into this kind of configuration where I have A over A naught. Well, here, right, when I do this, I have A naught over A. But remember, if I take the reciprocal of this, then I would flip this up, which means I'd flip this. Because remember, this is really underneath 1. So when I flip this, this is the fraction that remains. Often I'm going to ask you for a percent remains. You're just going to divide those two. That will come in future problems.